Hello, my name's Graham Scarr and I work as a biologist and retired osteopath in the UK. And today I want to talk about the 6-strut tensegrity model, or Tensegrity icosahedron. A central point of biotensegrity, which is biological tensegrity, as first proposed by Stephen Levin. And as it's a rainy Sunday afternoon, we're going to make one of these tensegrity models, but rather than using lots of different strings, there's lots of examples on YouTube of how to make this. We're going to use just a single string, which may look a bit complicated to start with, but once you've mastered it, it's actually much quicker and neater. So away we go with our 6 struts that have a slot on the end of each one and our single piece of string. We slot the string into the end of one of the struts, then measure about 60% of the length of the strut, that's half and a bit more, and insert it into the end of one of the second strut in the same distance again, back to the end of the first strut, 60% again to the third strut, then back to the original starting place. So we have a T with 2 verticals. Make sure you keep the original end with the bit hanging up as a reference point. That's a horizontal reference point. So now we'll go to the 4th strut, which will eventually be a horizontal. I won't describe every step on the way because it gets a bit complicated, but you can see diagrams and instructions at the end of my book, Biotensegrity, the Structural Basis of Life, by handspring. So now we take it back to the original horizontal. Biotensegrity, well, tensegrity structures are very efficient structural arrangements, which is why I have so much interest in biology, which is also very structurally efficient, very energy efficient. Why there's so much interest? Because when you move a tensegrity structure, move one part, the whole structure changes shape, all in one go. There's also more on my website, tensegrityinbiology.co.uk, and have a look at Stephen Levin's website, biotensegrity.com. If you're doing this really properly and really carefully, I'd have a little ruler on the table and be measuring each one, but for demonstration purposes this is good enough. My largest model consists of 120 of these 6-strut tensegrities, which would take forever if you were to use lots of different strings for each one, but the single string method, so much quicker. So there we go. If it's not exactly right, you can just tweak the strings to make it perfect. So thank you for watching, and have a go yourself.